Survival on solar system planets, a deadly journey through space. The universe is no place for humans. It is cold, lifeless, and full of threats that can destroy us in fractions of a second. Every planet in the solar system is a unique trap created by nature to remind us how fragile human life is. But what if we decided to challenge these worlds? What if we embarked on an imaginary journey where a human, without protection, without technology, without a spacesuit, finds themselves on the surface of each celestial body in our system? Welcome to Strange Attractor, where we explore not only the physics and nature of space, but also the limits of human endurance. Today we will journey from scorching Mercury to icy Pluto, measuring life not in years, not in days, but in seconds. This is not just a scientific experiment, it is a reflection on what it means to be human in the merciless void of space. Before we begin, it is important to understand what happens to the human body in the conditions of space vacuum. This knowledge will become the foundation of our journey, as most planets and moons lack an atmosphere capable of supporting life. Space vacuum, the first lesson of death. Space is not simply the absence of air, it is an absolute vacuum where pressure equals zero, and temperature can vary from absolute zero to millions of degrees near stars. The human body, created for Earth's conditions, is not adapted to such extremes. What would happen if an astronaut found themselves in open space without protection? Contrary to Hollywood myths, you will not explode or freeze instantly. Death in vacuum is a slow, agonizing process that takes 20 to 30 seconds of consciousness. The first thing you will feel is the sudden expulsion of air from your lungs. The pressure inside your body, approximately 760 millimeters of mercury, is 760 times greater than the external pressure of vacuum. This causes rupture of small blood vessels in the nose, ears, and eyes, and can lead to lung damage. Eardrums burst, causing sharp pain. Then the decompression process begins. Fluids in the body, especially on mucous membranes, begin to boil at low pressure. Saliva on the tongue turns to foam, and moisture in the eyes and mouth evaporates. Paradoxically, this evaporation can cause local cooling, freezing the mucous membranes. The skin stretches as gases in tissues expand, increasing body volume by approximately twice, but it is elastic enough not to burst. A real example of such a scenario occurred in 1966 with National Aeronautics and Space Administration engineer Jim LeBlanc. During tests in a vacuum chamber, a malfunction occurred and the air supply tube in his suit broke. He lost consciousness after 14 seconds, but the last thing he remembered was the sensation of boiling saliva on his tongue. Fortunately, he was quickly returned to normal conditions and survived, though for a month he could not distinguish tastes. If a person is not returned to normal conditions within 30 seconds, irreversible asphyxiation begins. Oxygen in the blood is depleted, the brain shuts down, and the heart stops. This is not a spectacular death like in movies, but a quiet, fully conscious tragedy. And this scenario will be the starting point for most planets in our solar system. But some worlds offer more sophisticated methods of destruction. Let us begin our journey. Mercury, the planet of three deaths. Mercury, the closest planet to the Sun, is a world of extremes. Its surface lacks an atmosphere that could soften the impact of solar radiation or distribute heat. During the day, temperature reaches 427 degrees Celsius, enough to melt lead. At night it drops to minus 180 degrees Celsius, turning the surface into an icy desert. These fluctuations are due to the absence of atmosphere and the planet's slow rotation. One day on Mercury lasts 59 Earth days. If you find yourself on the sunny side, solar radiation will burn you in seconds. Ultraviolet and X-rays will penetrate the skin, causing third-degree burns and destroying DNA. On the shadow side, cold will instantly freeze tissues, turning them into fragile ice crust. Even if you materialized on the Terminator, the boundary between light and shadow, where temperature could theoretically be tolerable, vacuum would kill you as quickly as in open space. Lack of oxygen and decompression would do their work. Mercury is a planet where death comes from three directions at once: heat, cold, and vacuum. Even if you could somehow avoid one threat, the other two would finish you in mere moments. An autopsy might be the only way to determine exactly what killed you. Survival time, 3 seconds. Venus, the planet of hellish embrace. If Mercury offers quick death, then Venus is a workshop of slow but inevitable torment. This planet, often called Earth's evil sister, has an atmosphere, but it is so hostile that it would be better if it did not exist at all. Atmospheric pressure on Venus is 90 times greater than Earth's, equivalent to pressure at a depth of 1 kilometer underwater. Such pressure would crush the human body in fractions of a second, compressing bones and internal organs into a shapeless mass. Even if you could somehow withstand the pressure, the temperature of 460 degrees Celsius, above zinc's melting point, would burn you to charcoal. The atmosphere, consisting of carbon dioxide with sulfuric acid clouds, adds a chemical threat. Breathing it would poison you with toxic vapors, though you likely would not live to that point. Venus is a planet where every aspect of the environment is lethal. Pressure, temperature, chemical composition, everything works against you. Even if you somehow found yourself in the upper atmospheric layers where pressure and temperature are closer to Earth's, lack of oxygen would still kill you in seconds. Historically, Venus was considered a potentially habitable planet. In the early 20th century, scientists assumed that jungles or oceans might hide beneath its clouds. Soviet Venera probes in the 1960s and 1970s showed how mistaken these dreams were. The Venera 7 probe became the first device to transmit data from another planet's surface, but it lasted only 23 minutes before being destroyed by hellish conditions. Survival time, half a second. Mars, deceptive hope. Mars is a planet that entices us with its similarity to Earth. It has seasons, polar ice caps, and days almost identical to Earth's, 24 6/10 hours. Mars's red landscapes resemble Earth's deserts, and it seems like you could survive here. But this is an illusion. Atmospheric pressure on Mars is only 0.6% of Earth's, about 6 millibars. This is below the Armstrong limit, approximately 60 millibars, the point at which fluids in the human body begin to boil at body temperature, 37 degrees Celsius. Saliva, sweat, tears, and even blood in your veins would begin turning to vapor, causing vessel and tissue rupture. This process, called ebullition, would begin instantly and be accompanied by excruciating pain. Temperature on Mars varies from 20 degrees Celsius in equatorial regions during the day to minus 140 degrees Celsius at night. If you found yourself on a warm day at the equator, you might feel almost comfortable for a moment, until you started suffocating or your fluids began boiling. Mars's atmosphere, consisting of 95% carbon dioxide, contains no oxygen necessary for breathing. Additionally, Mars subjects you to radiation. The absence of a magnetic field and thin atmosphere mean cosmic rays and solar radiation reach the surface unimpeded. In a few minutes, you would receive a radiation dose equivalent to several years on Earth, causing acute radiation sickness. Mars is a planet that teases with hope of survival, but ultimately kills mercilessly. It is a place where dreams of colonization collide with the harsh reality of physics. Survival time, possibly a full minute. Jupiter, gravitational grave. Jupiter is not a planet in the conventional sense, but a gas giant with no solid surface. If you land on Jupiter, you will simply begin an endless fall through its atmosphere, consisting of hydrogen, 90%, and helium, 10%. As you descend, pressure and gas density will increase, and temperature will rise from minus 110 degrees Celsius in the upper clouds to thousands of degrees in the depths. At a depth of about 100 kilometers below the cloud cover, pressure becomes comparable to Earth's, and temperature becomes tolerable. But you will not reach this level. Lack of oxygen will cause suffocation within 30 seconds. If you fall fast enough, friction against the increasingly dense atmosphere will turn you into a meteor, burning in a bright flash. Jupiter also possesses a powerful magnetic field that creates radiation belts thousands of times more intense than Earth's Van Allen belts. Even if you somehow survived the fall, radiation would destroy your cells within minutes. Jupiter does not just kill, it erases you from reality, leaving no trace or possibility of rescue. Survival time, 30 seconds or hundredths of a second. Saturn, Uranus, and Neptune, Trinity of Death. The gas giants. Saturn, Uranus, and Neptune follow the same pattern as Jupiter, but each adds its unique threats. All three lack solid surfaces, and their atmospheres consist of hydrogen, helium, and traces of methane, excluding the possibility of breathing. Saturn, with its magnificent rings, seems deceptively attractive. But falling through its atmosphere would end the same as on Jupiter: suffocation or burning from friction. Temperatures in the upper layers are about -140 degrees Celsius, and pressure increases with descent. Radiation here is less intense than on Jupiter, but still lethal. Uranus adds extreme cold, -220 degrees Celsius, and a methane atmosphere that makes the air toxic to this cocktail. Its magnetic field, tilted 59 degrees relative to the rotation axis, creates chaotic radiation belts that would irradiate you before you even start suffocating. Neptune, the most distant gas giant, offers winds of up to 2,100 kilometers per hour, 5 times the speed of sound on Earth. These winds would tear you apart if you somehow survived the cold, -200 degrees Celsius, and pressure. Each of these worlds kills quickly and mercilessly. The choice between suffocation, crushing, or burning is all they offer. Survival time, less than a second for each. Titan, cold hope. Titan, Saturn's largest moon, is an anomaly in the solar system. It has a dense atmosphere, 50% thicker than Earth's, with pressure of about 1.5 bar. This is the only known moon with a full atmosphere that could theoretically support a human without a high-pressure suit. But not everything is so simple. Temperature on Titan consistently stays at -180 degrees Celsius, making it deadly cold. The atmosphere consists of nitrogen, 95%, and methane, 5%, with no traces of oxygen. You will freeze or suffocate. The question is only which happens faster. Titan is also unique for its methane lakes, rivers, and rains. The surface resembles Earth, but instead of water, liquid methane flows here. If you could breathe and withstand the cold, you could see orange skies and landscapes resembling Earth's deserts. But reality is that 30 seconds is the maximum you will last before cold or suffocation ends your journey. Survival time, 30 seconds. Europa, ocean under ice. Europa, Jupiter's moon, is a world that entices scientists with the possibility of life beneath a thick ice crust. Under the ice lies an ocean of liquid water, possibly twice as large as all Earth's oceans. But for humans, Europa's surface is a deadly trap. Temperature here is about -150 degrees Celsius, and atmosphere is practically absent, consisting of a thin layer of molecular oxygen unsuitable for breathing. Gravity on Europa is only 13% of Earth's, which would allow you to move with ease, but this will not save you from radiation. Jupiter's magnetic field creates radiation levels on Europa that can kill a human in several minutes, destroying cells and DNA. Europa's surface is covered with cracks and geysers, ejecting water vapor to heights of 120 kilometers. These geysers are evidence of subsurface ocean activity, but they will not help you survive. Cold, vacuum, and radiation will do their work faster than you can admire the icy landscape. Survival time, 15 minutes. Pluto, at the system's edge. Our journey concludes on Pluto, a dwarf planet at the solar system's outskirts. Pluto is a small world with a diameter of only 2,380 kilometers, smaller than the Moon. The Sun here looks like a bright star, and its light takes more than 5 hours to reach the surface. Temperature on Pluto drops to -220 degrees Celsius, and the atmosphere, consisting of nitrogen, methane, and carbon monoxide, is so thin it is practically indistinguishable from vacuum. Gravity is only 6% of Earth's, making movement easy but not saving you from cold. Pluto's surface is a frozen desert of ice and rocks, with mountains, valleys, and plains resembling Mercury's dark side. In the year 2015, the New Horizons probe showed that Pluto is surprisingly active for such a distant world, with signs of geological activity. But for humans, this does not matter. Cold will penetrate any spacesuit within minutes, causing material brittleness and system failure. Vacuum will complete what was started, and you will perish. Survival time, 8 minutes. Epilogue. The meaning of fragility. Our journey through the solar system is complete. We measured human life in seconds and minutes, confronting harsh reality. The universe was not created for us. Every planet and moon is a unique form of death, from Venus's scorching hell to Pluto's icy desert. Mercury burns and freezes, Mars deceives with hope, gas giants erase you from existence, and even the most hospitable moons like Titan give only brief moments of life. But in this hostility lies deep beauty. It makes us value Earth, a unique oasis where life could not only emerge, but flourish. Every breath, every ray of sunshine, every moment of existence is a miracle we often take for granted. Our fragility, our dependence on Earth's delicate balance of conditions, this is not weakness, but a reminder of how precious life is. Elon Musk and other visionaries speak of colonizing other planets as a way to ensure humanity's survival. But our journey shows this path will be incredibly difficult. To survive on other worlds, we will have to take part of Earth with us. Air, warmth, protection from radiation. This is not just a technological task, it is a philosophical challenge. Can we preserve our humanity while leaving home? Ultimately, our journey through the solar system is not only about death, but about life. It is about how awareness of our fragility makes us stronger, forcing us to value every moment and reach for the stars despite all difficulties. If you enjoyed this journey to the edge of human survival, support the video with a like and subscribe to Strange Attractor. We continue exploring hidden patterns of reality. From quantum paradoxes to the mystery of consciousness, from the great filter to humanity's future among the stars.